In this video, I'll show you step by step how to draw these 7 forms: the folded paper or cloth, a sail on a sailboat, a tent, uneven terrain, and several bridges. And I'll also provide you with some tools to deal with other curved figures. A curve that is two-dimensional with only height and width is the easiest one to draw. What if you want to transfer it to a perspective view? Divide up the original one into a grid with horizontal and vertical lines. Then divide the perspective view into the same number of units and transfer each part of the curve, like the beginning of the curve here would be transferred to this area on the perspective grid. There are several ways to draw 3D curves, and this is one of the simplest ways. Divide a box into 4 equal units, both in back and in front, and then create planes for at each of these units. Define what you want your curve to look like and repeat it in the front and back. And then connect like areas together, like the tops are connected together and the lowest parts are connected. And when you shade it, you'll get a shape like that. This curve was done the same way, it's just more complicated. And again, we have the top of the curve, which is duplicated below, even though part of this curve here isn't seen, like here and over here, that part of the curve we can't see because it's behind the form. And then you connect like parts together with vertical lines. I'm now going to show you several examples of curves on 3 axes. We'll start with this one, which could be interpreted as a sail for a sailboat. To make this, draw a grid with lines going to the left vanishing point and others going to the right vanishing point. Then put in the green ellipse that seems to recede toward the left and the orange ellipse that seems to recede toward the right, both of them ending up on the grid. Although neither of these ellipses have vertical axes, they seem stable since they share this central vertical pole. The final part of the curve is the base, which must have a vertical axis even though it's not explicitly shown, because that gives stability to the form. It's important to position ellipses properly, otherwise the image may not look real. I'm now going to show you how to draw this cute tent. First, start with the box, then find the center of the base where the 2 diagonals cross. And from this center, draw lines parallel to each side of the box, going this way and then going this way. Once they reach the side of the box, they go directly upward. These become the axes of the arches. In this diagram, I put in the ellipses that are to represent the arches. And notice that their major axes lie on these magenta poles. I then put in the arches in the back, again using the magenta poles as their peak. We end up with a box containing 4 arches. I shaded them to indicate that the magenta arches are in front of the blue ones. Then draw in the top. Here I have some sag in the roof, so the middle line should also appear to be sagging. How do we know that the front of this tent is being pulled backward? Normally, the opening would follow a half ellipse, as I've shown here, with the major axis being vertical, because it's a supporting structure. Since the tent I drew doesn't follow this curve, we know there must be another force acting on it, which is the pull from the back. This is a useful way to create an uneven terrain that looks more realistic than a freehand drawing. Start with the grid and then add posts to represent the vertical extent of the final figure at each point, and then connect the tops of these posts both horizontally and vertically, and you'll end up with this form right here. The rest of the video will cover some simple approaches to parabolas and hyperbolas. They're conic sections, meaning that they're shapes resulting when planes cut through a cone. A circle results when the slice is horizontal and all points are the same distance from the center. An ellipse results when the slice is diagonal. A parabola occurs when one side is parallel to the side of the cone. So this side of the cone is parallel to this side of the parabola. While a hyperbola results when the slice isn't parallel, although it's usually parallel to the axis of the cone. Here we have a parabola where one side is parallel to the side of the cone. When you throw a ball or shoot an arrow, they follow parabolic curves. A parabola can span a wide area, so they're used for suspension bridges. And satellite dishes are also parabolic. To draw the Golden Gate Bridge, define the edges and divide them into the same number of units, but have the units on one line, for example here, be smaller than the units on the other line. Then connect numbers so that number 4 is connected to number 1 on the other line, number 3 is connected to number 2, etc. And you end up with a curve that looks like this, that's parabolic. So it's a very easy way of making a parabolic curve. Then connect the parabola to vertical lines down to the base of the form, giving it stability. And finally, overlay one parabolic curve over the other to give the 3D form of the bridge. Another way to draw parabolas is using inclined planes. So start with a line that is divided into equal units, and then draw rectangles that converge toward each unit. For example, this white rectangle converges toward this top dot, and the yellow rectangle converges toward the dot below that. And you keep on going until you get a curve that looks like this. And shade the front part lighter than the underside so that we know which is in front and which is in back. A hyperbola usually cuts through a cone so that its axis is parallel to the axis of the cone. And a wall does just that. It cuts through the cone of light from a ceiling fixture so that it creates a hyperbola. Hyperbolas are more spread out than parabolas and can come in many different shapes. A parabola, in contrast, has only one shape. A hyperbola is found when a wall cuts through a cone of light from a ceiling fixture. A parabola is seen with the trajectory of a ball that's thrown and a suspension bridge. Take a look at my book, Ellen's Guide to Drawing Shapes, found on Amazon. And please leave comments on this site or using my email here. See you next time.